In this video, we are continuing revision of Mathematics Paper 220, 22 GCE. Now, from the question, we can see that we are dealing with the Earth geometry. That is the topic that we are trying to answer here. Now, in the diagram below, M, L, and K are points on the surface of the Earth. Take pi to be 3.142 and radius 3437 nautical miles. Okay, so now from the diagram, we can see that we have the lines drawn in green and these drawn in red. So the lines drawn in green are known as longitudes. So we have the longitudes, and the longitudes are lines that runs from the north to the south of the equator. Then for the ones drawn in red are known as the latitudes. The latitudes runs from the west to the east of the prime meridian. Okay. Now after identifying this, we can see that we have point M. We also have point K and point L. Now the first question is Roman number 1, determine the difference in the longitude between points M and K. So our focus, we want to find the difference between M and K in terms of longitude. So we are going to find the longitude where M is and the longitude where our K is. So we can see that the longitude for M is 48 degrees west. The longitude for K is 32 degrees east. So if you have one longitude located west and the other one located east, for you to find the difference, you need to add the two longitudes. If the two longitudes were on the same position, if maybe we can say 48 west, then 32 west, we would have subtracted. So subtraction is done if you have 2 points on the same position. So now we'll say difference. So longitude for M, we have 48 degrees plus 32 degrees. So if we add, we can do mathematics. 48 plus 32, we get 80 degrees. So this is the difference in the longitude between points M and K. Now, after finding the difference, we can now proceed with question to calculate in nautical miles the distance between M and K. So let's find the difference between M and K. So this distance here is, so here we have the center here. So this distance is what we are trying to find here. So the distance M and K in nautical miles. So now we can see that the distance that we are trying to solve lie on the latitude. The distance that lies on the latitude, except for equator, these are known as the shortest distance because they are found on the small circles. The latitudes, apart from the equator, the remaining latitudes are known as the small circle. So if you are finding the distance along the latitude, the formula is distance is equal to theta over 360 2 times pi times r cos x. So which means we need a theta. The theta is the difference in longitude of which we have it. So we can now say distance is equal to theta is 8 degrees over 360 multiplied by 2 times pi 3.142. Radius, we have been given the radius here 3437 cos. Now the value to plug where x is, it is the latitude where the distance lies. So we are looking at the distance that lies on latitude 80 degrees. So where there is x, we substitute with 80 degrees. So we can now do mathematics. So we can just say 80 times 2 times 3.142 times 34, 37 multiplied by cos 80. So we have 300,000 37.76 not commas. So after what I've just done here, I've only multiplied the numerator part. So we can now continue the same number now divided by 360. So on my calculator, I can get 833.44 nautical miles. So this is the distance for question A, M and K. Okay, now let's move on. We look at the distance K and L. So now for K and L, we are able to see that K and L lies on the longitude. So this time we are finding the distance when the two letters lie on the longitude. So the formula is distance is equal to theta over 360, then 2 pi r. So if you are finding the distance in longitudes, the cos x must not be added to the formula because the longitudes are considered to be the great circle, and therefore their radius is equal to 34, 37 in nautical miles, 63, 70 in kilometers. So we don't include cos x. But what we are going to do is we need to find the difference in latitude. So if you are calculating the distance along longitude, find the difference in latitude. So let's look at the latitude for K. So the latitude for K is 8 degrees north. Then the one for L is 85 degrees south. So we can see that one latitude is on the north part, the other latitude is on the south part. So we need to add for us to find the difference. So we'll say difference in latitude is equal to 80 degrees plus 85 degrees. So 80 plus 80, we have 160 plus 5, so we have 165. This is our difference in latitude. So we can proceed. We have distance is equal to 165 degrees over 360 multiplied by 2 times our pi, 3.142 times our radius, 34, 37 nautical miles. So we can multiply the upper part. We can so 165 times 2 times 3.142 times 34, 37. So I can get 3,563,687.82 nautical mile divided by 360. So distance is equal to, we can say now divided by 360. So I can get 9,899.13 nautical miles. So this is the answer for B, we can say this is as the distance for K and L. Okay, so now if we can do the comparison, we can see that the distance along latitude was 833. Therefore, for the distance in the longitude, we have 9,000. So we can see that the distance in the longitude is greater than the distance along the latitude, because the longitudes are considered to be the great circle. So we can, if we are able to draw this, you can see that this distance here is greater than this distance here. Okay, now we can move on to question B. The diagram below shows the frustum of a cone. The top and bottom diameters are 6 centimeters and 18 centimeters respectively. Take pi as 3.142. Okay, so now a frustum is just a part cut from a cone. So what we are going to do is first let's look at the equation. Given that the perpendicular height, so the perpendicular height is 10 centimeters, calculate the volume of the frustum. Now for us to calculate the volume of the frustum, first we are going to conclude this frustum. We have to make it so that it becomes a complete cone. So this is how it was. So as we can see, we have this small cone that I've added in the green. So if we are able to find the volume of this small cone and we find the volume of the big cone, so if we now subtract the volume of the small cone from the volume of the big cone, we'll be able to find the volume of the remaining part, which is the frustum. Now, the formula for, we can say now, volume of the frustum, we'll say 1 over 3 pi r squared h. So the radius for the radius and the height for the big cone will be denoted using capital letter. So minus 1 over 3, or let's just say volume of the cone. So we just say volume of the frustum is equal to volume of big cone, minus volume of small cone. So this is where the concept is coming from. So volume of big cone, the formula is 1 over 3 pi r squared h minus then the volume of small cone 1 over 3 pi, this time our radius and our height will be written using the small letter. So if you want, we can factorize 1 over 3 and the pi, since they are common in two formulas. Now let's look at see if we have any missing. So here we have been given the diameter for the big circle, and also we have been given the diameter for the small circle here. So now, in order to find the radius is just the half of the diameter. So the 6 centimeter, the diameter for the small cone, we can say we have this one. So if the diameter is 6 centimeters, the radius is 3 centimeters. So half of the diameter gives us the radius, and the radius for the big cone will be half of 18, which is 9 centimeters. Now, for us to calculate the volume of the frustum, we need to have the height now of the big cone. So we have a missing value. So we are going to find the height of the small cone. Then if we have the height of the small cone, then the height of the small cone plus the height of the frustum, we have now the value, which is the height for the big cone from here up to there. So what we are going to do is we are going to use the principle of similar figures. So what we are going to do is we'll say height of the small cone divided by height of the bigger cone is equal to, we can say, radius of the small cone divided by radius of the big cone. So height of the small cone is x, we don't have, over height of the big cone is 10 centimeters plus the x. So we'll say 10 centimeters plus x. Then radius of the small cone, the half of 6 is 3 centimeters over radius of the big cone is half of 18 is 9 centimeters. Then we cross multiply. So we can see 9 centimeters times x, we have 9 centimeters x. Then 3 centimeters we multiply with 10 centimeters and x. So 3 centimeters times 10 centimeters, we get 30 centimeters squared plus 3 centimeters times x, we have 3 centimeters x. So we can collect like terms. So these 3 centimeters will shift to the other side. We have 9 centimeters x minus 3 centimeters x is equal to 30 centimeters. Now, centimeter squared is same as the centimeter times centimeter. So 9 centimeters minus 3 centimeters x, we get 6 centimeters x is equal to, now our 30 centimeters squared. So centimeter squared, I will just write it as centimeter times centimeter. So that when I divide the 6 centimeters also here, 6 centimeters, we can see that our x is equal to, we'll cancel 1 centimeter from the numerator and the one from the denominator. So 6 into 30, we have 5 centimeters. So this means that this distance here is 5 centimeters. So now the height of the big cone in total is 15 centimeters. So we have the height for the big cone and the height for the small cone. Now the other thing that I can also look at, if we don't want to use the radius, we can also use the diameter in order to find the missing height. So this one will be, we can say height of the small cone divided by height of the big cone, but instead of finding the radius, we just use the diameter the way they are. So we'll say diameter of the small cone divided by diameter of the big cone. So height of the small cone is x over height of the big cone is 10 centimeters plus the missing value x. Diameter of the small cone is 6 centimeters divided by big cone 18 centimeters. So we can cross multiply 18 centimeters times x, 18 centimeters x. Then 6 centimeters times 10 centimeters, we get 60 centimeters squared plus 6 centimeters times x, 6 centimeters x. So we shift the 6 centimeter to the other side, so we get 18 centimeters x minus 6 centimeters x is equal to 60 centimeters squared. So 18 minus 6, we get 12 centimeters x. Then 60 centimeters, I'll just write them centimeter times centimeter, so that when you divide by 12 centimeter, also this side the 12 centimeter, we cancel, we get x is equal to, cancel 1 centimeter, 12 into 60 is still 5. So if you have a question where you have been given diameter, for you to find the value of the height for the smaller cone, you can use height of the smaller cone divided by height of the big cone is equal to, you can use diameter over diameter or radius over radius. You get the same answer. So now we can proceed. We have volume is equal to 1 over 3. Pi is 3 point, we have been given 3.142. Then radius of the big cone. So radius now, here we can't use diameter when finding the volume. So we need to find we have the big circle here for the large cone, and we have 18. So for you to find the radius, if you are given diameter, just divide by 2. So 18 divided by 2 is 9 centimeters. So the radius for the big cone is 9 centimeters. Now squared. The height is 10 plus 5, 15. 15 centimeters minus 1 over 3, 3.142. Now, radius of the small cone, half is 3 centimeters squared. Now, the height for the small cone is the 5 centimeters, the one that we calculated. So, we get 5 centimeters. So, we have volume is equal to, so we can reduce 3 into 3, 1, 3 into 15, 5. So here I have 3.142 times 9 times 9, we get 81 centimeters squared. Where the squared is coming from is 9 centimeters times 9 centimeters. Then multiply by 5 centimeters minus, so even here we can cancel 3 here, 1, 3 here, so we just have 1 3. So 3.142, you can use calculator, it's fine. So 3 centimeters squared times 5 centimeters. So we can say volume is equal to, now we use calculator, so we have 3.142 times 81 times 81 times 5. So mine is giving me 1272.51. The units for volume must be cubed minus, then we also have 3.142 times 3 times 5. So this one is giving me 47.13 centimeters cubed. So we can now subtract minus. So the value is 1225.38 centimeters cubed. So these are the answers for this question. Thanks for watching.